So welcome today to this webinar. I'm Cyprian from Midas, and I'm here with Piotr Stepien.
Hello everyone.
So we're very glad to be here today to present this webinar about simulation features in depth. So today we'll talk about a lot of things, and we'll also answer some practical questions because we prepared some examples which are coming directly from our clients to show you the useful features of the software and also compare everything. So I hope that after this webinar you'll see much more clearer what are the FEA features which are important for you. So I would like to start with the problem, which means on one side why we decided to do this webinar, and the thing is that everyone who wants to do FEA start with a typical problem that they want to solve. So typically engineering problems, so mechanics, or they have a new design and they want to test if this is strong enough. So the typical process to do that is simply to do physical testing, for example. So you have to drop tests, crash tests, or anything you would need to do on this model. But I think if you are interested in FEA, you know that all those testing are necessary, but they also cost a lot, and everyone actually would like to use the computer to simulate all that to be much more efficient by taking all this process in a numerical way. So of course, when you think about that, you start to do some research about software packages, what is CAE, and what kind of analysis you have, and what kind of features. So and then you discover one software, maybe Nastran, and then you discover another one, and then you discover another one, and another one, and another one, and there's so many things that you could learn about FEA, because this is something that is on the market for so many years that people had the time to implement a lot of features, a lot of needs from all the industries. So generally these software are quite complex. So the thing that you could ask yourself is, how do I choose maybe a software? How do I know what are the features that I need? How do I know which software is better than another for my problem? So all these questions are all the things that you are wondering when you first see FEA software. So the first reaction, I think, as an engineer is to go on internet and just search for a comparison between different features. So you find big tables from different sources. So, oh, you have this feature, and this feature. Every table is different, so you have to compare, oh, what is the equivalence between the different features, and everyone is using a different name for that. So all these things are very difficult, so you don't know basically. So you're like, oh my god, I need to have a software to analyze something very simple, but at the end I get something which is quite complex, and I don't know how to choose the right software for me. So today in this webinar, what I would like to do is to try to make it simple for you to understand a few features that are important for you, more important than others. And this is the process that I think is very important. So the first thing is to understand which engineering problem do you really want to solve. So because if you want to use FEA, this is because you have some model to check, you have some analysis to do, you need to know the stress in a specific part, or you need to know if it breaks, or maybe, but and this will give you basic requirement that you need for a software. For example, if you only need to check the design, you will only need a basic package. So the most basic linear static analysis, for example. But if you need to analyze something more complex, like for example the dynamic behavior of composite material, then you will need something much better. The second step, the second question that you need to ask yourself is, do you really need a professional FEA or just simple FEA for design purpose? So what's the difference? The difference is professional FEA is you have much more features, you can do everything you want, but it's also much more difficult to use and to learn, and it's much more expensive as well. So it depends on a lot of factors, and simple FEA is more simple, less expensive, but it's limited, and you don't have all the features you need to analyze complex models. So it really depends of what you want to analyze. For example, what is the size of your model? Is it a simple part, or is it an assembly of 10 parts or more? So just in function of this simple question, you can decide which software is suitable for you, because some software can only handle 2 or 3 parts maximum, and it will be much more difficult to have bigger assembly. So this is the second important question. And the third one is, what are the features that I really need? Because this is something that maybe the beginners don't understand when you see the first time, because there's so many features that maybe you're thinking, oh, I need everything. Actually, there's a lot of features that you will never use, because companies who develop FEA software, they have been here for years and years, and they develop so many features that sometimes they are useful for one typical industry, very specific, but not for you. So you don't really need everything, but there are some features that you need, because this feature will make you save a lot of time and money. So, but you have to know which are those features that you need that will help you. And this is the purpose of today's webinar, because I want to show you which are the main features, let's say, that we are using every day and our users are also using. And we'll do some practical demonstration about that and talk about that as well. So if I'm going too fast, or if you have some questions during the presentation, please ask them directly in the section, and we'll try to answer them in live, or maybe at the end. We'll see if we have the time. Now, the first important thing is to understand the structure of almost every FEA software is constructed in 3 parts. And this is the most important thing that you have to know first when you are searching for a software, because every feature that you will see will correspond to one of these 3 parts. So the first is the pre-processing, which is also called model preparation. So this is basically when you use the graphical interface of your software to build the model. So you will need a lot of different features that will help you to build the model, and that will help you to build the model more accurately than another model. So these are the pre-processing features. Then, once you build your model, you will send it to the solver. So at this stage, your software will run the algorithm and calculate based on your input, and then it will give you the results. So if your model is correct, of course. If your model is not correct, it may not give the results, but that depends on you. So you will get the results, and this is the post-processing step. So basically these 3 steps, so every software is different, and some software are very good for pre-processing, but are a bit weak in the solver step, which means what? Which means that they have older solvers, or maybe the solver is not so fast. So and you have some software which are better on post-processing maybe. So you have to know to spot what is, let's say, the weakness of the package that you are thinking about, because some packages are hiding this from you actually. So when you go on the website, you see only the good things, you don't see what is not good. So now I'm telling you that because I know, and I am showing you everything to be frank with you. So I will tell you also if we have some weak points or something. So it's not about that, but I would like you to understand this very clearly. So midas NFX is a FEA package which has the particularity to integrate every type of analysis in one unique package. So this is unique on the market because every other software package has, let's say, is limited to a certain type of analysis. Some packages are strong in linear but cannot do CFD, multi-body, or other types of analysis. So NFX has everything in one package, and this is the only software which has structural analysis and fluid dynamic analysis in one unique package. So you can literally build one model and analyze the structure and then analyze the flow inside. And you can even link the two because we have now fluid structure interaction. So you can also do optimization. So if you're a designer, you can optimize your model, then you can run linear static and all of that. I will detail that a bit later in the presentation because this is only to show you what is midas NFX. Now, where do you actually place midas NFX in the other package available on the market? So you have two types, let's say, of softwares. You have the professional FEA softwares, which are more generalist and targeted for the FEA analysts who really have a lot of experience in FEA. And you have the packages which are integrated into CAD software, so targeted for the designers. So here you see a list of the software which are targeted for each of these segments. And the other particularity of midas NFX is that we have two modes actually. We have one analyst mode and one designer mode. So if you work in analyst mode, NFX will be equivalent to a professional FEA software. So you'll have everything pre and post processing, which is similar to those softwares. But if you're working in the designer mode, you will be equivalent to let's say a software in CAD. So more easy, less choice, but more faster for the analysis. So this is the two modes I was talking about. So on the one side you have midas NFX Designer Mode, which is more easy, and on the other side midas NFX Analyst Mode, which is more professional. So you can also go from one to another, and we are providing all that in one package, which means that you don't have to buy them separately. You can have both, which means if you are a designer but occasionally you want to do professional analysis as well, you can very easily switch to the professional mode and run something more professional, more difficult. If you are a professional, then of course you will mostly run into the analyst mode, but sometimes if you just want to do some design check, or maybe if you're working with designers, you can use also the designer mode. So these two modes are both integrated with all NFX solvers. And I will talk about that later. Now I'll talk first about some features of the graphical interface. So I'll show you what I called previously the pre-processing, and I will discuss about some of those features, and then Piotr will do some small demonstration about some of the most useful features that our users are always asking us about. So the first thing, which is of course very important to know, is which kind of data you can support, you can import and work with inside. So which kind of CAD format is supported. This is very important because especially, let's say you are a consultant in FEA or something, then you will receive a lot of models from everywhere and you need to handle various formats. But so NFX is integrating a universal converter from more than 13 formats. So we are not developing the interface by ourselves. We got this interface from a French company, very famous for that. So you know, basically we support all those formats that are written on the screen. And as well, you can also import CAE data. So if you are working on Nastran, or if you have Nastran files, you can read that in NFX, you can import them. And also you can read all the formats. Now let's talk briefly about the geometry modeling approach in midas NFX, because what is also important to understand is that midas NFX has a very good geometry handling. Let's say you can create your geometry in the software almost as if you were in CAD. So I'm not saying that midas NFX is a CAD software, it's not, but a lot of people are telling us that you have this kind of practicality because you can directly sketch your model and draw it almost as if you were in CAD inside the pre-post of midas NFX. So it's very convenient because actually if you have just to sketch a small model, not so complex, you can directly sketch it in midas NFX. You don't need to go into your CAD software. And also this kind of features works like that. So you have the total control of the model. You can work on curves, on surfaces, on solids. You can mix everything together, and those are all the features which are supported to work on the geometry. So it's a lot of things, so I can be a bit more visual. So for example, Boolean operations, you can directly do that. You can trim your model, you can divide, you can sew the faces, and so it's actually very convenient to work on the model. So you can import your CAD geometry, you can simplify it, and this is also something very important, and this will be the subject of the first demonstrations by Piotr about the simplification of the model. What happened, you know probably that when you have CAD model, a lot of people are putting a lot of details inside the CAD models, a lot of fillets, a lot of small holes. All these things are actually complicating the simulation when they have no impact on the structural properties of your model. So it's not always the case, but there's a lot of time when you have a lot of small holes which are actually aesthetic, let's say, but not really impacting the stiffness of the model. And all these things are created difficulty for the simulation because the meshing will need to be smaller at some areas, and then you will introduce more mesh, and so a lot of people, what you want to do is just to simplify all that. So midas NFX provides such features of defeaturing directly inside the interface. So you have automatic defeaturing, so you can directly get the holes and get the fillets and remove them, and you have also manual types of defeaturing, and a lot of people are telling us that it's it's quite similar to Space Claim, some of the features to remove edges. So I never tried, so I don't know, but this is what I've heard. So these are a few examples. So for example, you can remove holes, remove fillets, and models which are very complex like that with small faces can be simplified for simulation. And I'm showing also that because this will be the subject also of one of the demo Piotr will do in a few minutes. It's called auto connection, and it's very useful to connect parts of an assembly together. So that's something that when you have, well, Piotr will show you how it works. So, okay, so Piotr, you can start. I'll give you the headset. And if you have questions also, please ask.
Okay, thank you, Cyprian. So welcome everyone again. This is Piotr, and right now we will start a bit our practical part of today's session. So let me switch to midas NFX, and for today's purpose, actually we decided to skip traditional demonstration, and instead of that we selected several models accordingly to questions which came from your side and from our customers. So we know that we promised this many times that we will prepare some kind of webinar according to your questions, so that's the opportunity to talk a bit about that. So I assume as well that some of you have some basic knowledge about working with the geometry, so there is no need to talk specifically about every type of the tool. So what I will do, I will just introduce to you quickly what we have. So all of the geometry tools are present in the geometry tab. So as you see, the interface is very, very modern. It has a ribbon tab, and every kind of tool can be very easily found. So basically what we will do in this demonstration, actually I would like to answer on the one of the question which comes to us very often. People are asking, for example, how to find broken edges inside midas NFX. So that's the part of the step which is called geometry simplification or geometry checking. It can be part of that and part of that in the same time. Everything depends on the complexity level of the geometry and on the things of the model that we have. So the basic answer about this question is yes, we can check, we can find broken edges. What does it mean? Broken edges are usually small edges. This is why I related this with the simplification. So let me show you where to find that, and let's talk a bit about the features, and let's do that. So basically we have some model which has been imported inside midas NFX, and where to find, how to check this. So if we go to this group of tools which is called Surface and Solid, we can find a tool which is called Merge Face Edge. So after clicking, we have an access to the option which is called Single Shape, and based on that we can select several faces or single faces actually, and the visualization for the points which are connected to the edges will appear. So now we are able to see where we have continuous edges or where we can find, for example, broken edges. So if we select this, we can see that this edge has been split into several small edges, which is not necessarily good if we consider to apply map meshing for some purposes. So basically how to remove that, we can select all of those edges, all of them, or we can, for example, select two just for the demonstrations. We can click apply, and once again we can display that, and as you see, the edge has been merged. So that's the first method that we can check for this. The second method is very intuitive, because we can go to the check shape. So this option, or this list of the tools, is inside the tools group. So I'm clicking on this check geometry, and from this actually we have several options related with the geometry checking. So basically, if we select our geometry and if we click on the check button, we can get the information about following features. So we can, for example, display free edges. This is very useful. We can display manifold edges, which will be displayed if I click second time on this button. So now we have it. We can check for the non-manifold edges, and if you take a look on this output place at the bottom of the software, you can see that everything has been reported as the text. So we exactly know how many edges has been detected. So, and finally, if we uncheck all of that, and if we specify, if we check this option which is called small edge, and if we specify the value, like for example 1, we can try to find the small edges. Right now we are working in millimeters, so let's specify something less, something smaller, and there is still nothing. And there is still nothing. So the question is if we have something around this area. So I was doing this example, so I know that something is wrong in that case. So, but let's close this tool and let's go to the simplify button. And from that you can also check the small edges, basically selecting this option and clicking on the find button. So this time, based on this tolerance, midas NFX found 2 edges, so we can highlight them, and there is fourth feature, which is if we double click on that, it will be magnified, and you are able to investigate the position or location where your bad feature, where your small edge is. So we have those options according to that, and I don't know any other way, for example, to search for the broken edges. So in the same time, if we maybe there is another method. So if we click on this manual tab, for example, we can check this option which is called show and hide, and this also gives us some idea where the broken edges are, because we can display the points. And in the same way, checking this button, for example, remove immediately, we can merge them interactively to create single surface. So this is how we can work with that. So that was one question. The second question was related to the simplification for the small edges, and actually I have a second example. So I will go to the simplify, and I will show you some manual techniques for removing some small edges. So basically, let's do the same step. Let's find for the small edges, and let's display that. So as you see, something, I hope you saw that something was wrong at this position. So we have some small edges, and we can try to delete them automatically. So we can select all of small edges and we can try to remove. But this is not a good idea for every type of the geometry, because as you know, the geometry can be less complex or much more complex, and sometimes sometimes the result could be like that. So how to approach this type of the problems? We have to go to Manual tab, and instead we can use option which is called merge faces. We have several options. We can remove points, we can remove faces, and of course there is no time to discuss about each option. I'm just giving you an advice what we can do. So what I will do for this particular example, I will use merge faces, and for that option I'm capable to let's check remove immediately. I'm capable to remove edges interactively. So let's remove that edge, and let's remove this edge. And as you see right now, the geometry looks much better, and the basis, the bottom of the solid doesn't change, which means this method was much more proper. So that was all according to the working with the simplification of the geometry. The second question was related with the mesh, but since the mesh is strongly related with the geometry, I would like to show you some practical usage of the command which is called AutoConnect. So basically the question was, how can I assure mesh compatibility? Because sometimes when I'm meshing, it's very difficult to assure the correct mesh or node alignment. This is what one of our customer asked us. So everything can start at the geometry modeling stage. So I imported this type of geometry to show you the idea how to work with this type of the issue. So our goal is to assure the mesh consistency, excuse me, between the parts. So if we go to the mesh, it's very important to start from this aspect. Like if we click on the 3D button, you can find the option which is called match adjacent faces. Okay, so everything is fine, but sometimes it's very difficult to find those faces, and in many cases we have to create them. And this is why the command which is called AutoConnect is very helpful. So let's select this option, and let's discuss some features about that. As you see, AutoConnect works in two modes. So there are two methods which are helpful for us. One is imprint and second is boolean. So for this first case, let me show you the advantage of using this first method, which is called imprinting. So what I would like to do, let's hide this part for the moment, and my idea is to create one single frame just for the checking the global stiffness of this model, and I would like to mesh this model as the single part. Sometimes it's very efficient to estimate the global deflections, so as you know, on the initial stage sometimes we are using this. Even before the simplification for the beam elements, it's up to you. There are many ways, so I'm just showing you how to do this imprint and how the feature works. So let me show you. So basically how does it work? So let's display all of that again, and let's select all of the geometries, and let's click on OK, and we will see the result. So let's wait a few seconds. Right now, if we hide this option, you see that the outside edges were imprinted on the parts, and because of that our mesh will be consistent on those parts. Or for example, we can assure the contacting faces the contacting faces will be, let's say, much more compatible. So in terms of the contact, we don't have to select all of them of the model, and number, specifically number of the contact elements will be less. So that's the second approach. And what else? What is interesting with this autoconnect? Of course, autoconnect can be used to imprint, for example, the shapes from your bolting connections. So that's a quick example. So if I select those two geometries, or those three geometries, and if I use the same option like imprint, I can very easily imprint the shape of the head, and after that I can use this model to simulate pretension of my bolts and rigid elements much more easier. For example, if I want to skip the solid elements. But the next feature, which is related to autoconnect boolean, this is very interesting, and for that I would like to show you the answer on two questions. The first question is how to project the curves to assure the mesh alignment, but another question was if it's possible to work with AutoCAD. So yes, it's possible. So this is what I'm showing you right now. So, we can go to the import, and we can import AutoCAD format with the DXF file extension. Excuse me. So I'm clicking this button, select the file. Let's go to AutoConnect and let's import DXF. So let's wait a bit. Okay, so as you see, that's the result of actually this is a preview of the DX file. So we can click on OK, and after that let's work a bit with the geometry using the traditional tools, and after that I will show you why the autoconnect boolean is also useful. So basically what I'm doing, I would like to extrude this shape, this gear, and create some solid. But before that, it will be very convenient to me to move this sketch to the initial position of the work plane. So how to do that quickly? So we can go to translate, and we can select our wire, our shape, and using these options we are able to move the shapes. But the problem is that this wheel has got circular shape, and we have to find some reference point. So that's another challenge for us. So basically what I'm doing right now, I'm unchecking this. I'm displaying only the circle, and I can create some reference point very quickly. So because using another feature which is called define snap, I have several options for the modifications, for the creation of the edges, for the sketching. So that's very useful. So let's do this. Right now I have my reference point. I can display everything again. I'm selecting those two shapes, and I'm moving my sketch to the position of the origin of the work plane. So I clicked as well at this button. This means that the distance has been calculated, and right now I can go to preview, and it's very convenient to see where the result of my operation. So I'm clicking OK, and right now let's hide this curve. We can create face very quickly. So this is one of the features that Cyprian was telling during the presentation, that we can work with the points, with surfaces and solids. So basically I'm doing this. I created face, so right now I can go to the transformation tools like protrude, and I can extrude this geometry. So let's extrude this as the normal to profile, or as or using the vector method. So let's check this option, for example. And there is one thing that I forgot to check. I haven't checked the scale of my model. So let's assume that the 1 will be okay for the extrusion. Okay, so let me show you this in that scale. So that's the 1 millimeter. So please don't remember this unit, because this is actually not so important at this moment. So 0.05, let's change the value. Let's go to the preview and let's create geometry like that. In the same time, let's create some shaft with the radius like this. So let me, maybe even bigger. And let's snap it to the gearbox. So for that, let me hide this extrusion, and let's place the cylinder on this position. So let's consider these two geometries. So as we see, one solid is embedded into the second one, and actually that's the goal. That's the practical usage of the auto-connect operation if we want to connect those two parts efficiently. So if we go to this Boolean operation, if we select both parts, we can click on OK, and we can see the result. So for that, let me hide everything else, and right now it will be much more convenient to operate with the model. So I'm going to hide the surface, and from that aspect actually I made some mistake. So let's move a bit, let's translate on the zeta direction this part. That's okay, so that's not a problem. Let's translate this. Let's preview. Okay, let it be 0.3. Let's click OK, and right now let's go and repeat this auto-connect operation. Let's select both of the parts, and that's the result what we have. So basically it's removing, it's cutting, and several operations are made in the same time. So right now Cyprian is back to continue the presentation about the meshing.
Okay, thank you very much, Piotr. So let's come back to the presentation, and let's continue about the other features. So we'll talk about material database, the meshing. So the material database is also very important inside the FEA software, because it conditions the type of material you will be able to use. So in linear static analysis you will use elastic material, and we have database of thousands materials which are already implemented inside midas NFX. And if you want to do nonlinear analysis and use nonlinear materials, you can also consider elastoplastic and hyperelastic or other types of material which are fully supported. For example, what you can do is implement the full stress strain curve inside the software to use that. So, but this is a bit more advanced. So you have also a lot of elements that you can use. So NFX not only supports the 3D solid elements, but support the full range of 1D, 2D and 3D elements. And each of them has different kind of properties. So you have 1D beam, truss, pipe, also cable, for example. And 2D you can use shell, plane stress, plane strain, axis symmetric, composite shell. All these things, all these element types can be used, and you have also all the types of elements which can be used to connect different elements together, or to represent different interactions like spring elements, mass elements, or dampers, fasteners, rigid links, interpolation links, bush elements. So those elements are much more advanced, but they are all available inside midas NFX. Now the meshing is of course very important, and inside midas NFX the meshing algorithms are very powerful, and they are using the multi-core processing, so it can mesh several parts of your model at the same time and use the multi-core of your computer to accelerate the process. So we did some testing, and with 4 cores, for example, it's 50% reduced of your meshing time. And because of that, a lot of people are telling us that the meshing in midas NFX is really fast in comparison to all the software they used previously. So when you have very big assemblies of parts, this is really something that will be useful for you, because you will not have to wait, and you know that maybe at the end the meshing will fail or something. Because I had a lot of questions from some people, and I didn't understand why. But it seems that in some other softwares the meshing part is very cumbersome, very slow, and actually you have to wait until the end of the meshing is done, and sometimes if one part fails, everything fails, and then you have to do everything again. So that's really annoying. But in NFX, for example, if one part fails to mesh, it happens of course, but then only this part will not be meshed, all the other parts will be meshed, and then you only have to mesh and to modify and simplify the part which failed. So all these kind of things, actually no one will tell you if you don't try the software and you don't see it by yourself, but that's something that makes a real difference, and that definitely is something very important. Also, we have not only very powerful and fast meshing, but also different type of meshing like hybrid meshing, which is fully automatic. So hybrid meshing is, I don't even know if it's supported in other softwares, because it's something actually that combines different type of mesh elements together, hexa, tetra and pyramid elements. And as you probably know, hexa elements are much better, much more accurate than tetra elements. So hybrid elements mix all that, and the advantage is that you have less nodes in your model, but you get the same accuracy. So for example, these two models, this one on the left has been meshed with tetra, and you get 160,000 nodes, whereas in this model on the right you get only 60,000 when you mesh in hybrid. So what's the difference actually if you have more nodes or less nodes? The difference is when you perform the analysis, the one on the right will be much faster than the one on the left. So it's approximately approximately 3 times faster. So you will, when you have a model that takes like hours to solve and you're using that, you have 3 times acceleration of your solving process. That's really something great, because instead of waiting for 10 hours, you can save 6 hours. So now the meshing is not only fully automatic in NFX, and that's something very powerful with the software, is that you have the full control on the meshing, and that's definitely not something that you have in every software. Actually, very few software now still provide such a control on your meshing, and specialists know that this is very important to have this kind of control, to create the perfect model that really fits the shape of your model and will give you the accurate stress distribution in the key areas of your model. So you have all these functions. You have the automatic measures, which are here. So basically these are all the automatic measures that you have. You have also automatic map measure, very useful. Those are the options to control the mesh size in the model. So on the lens, on the different characters of your model, to make the mesh smaller on some areas. Very, very important. And the different functions to play on the mesh. So to create nodes, to create meshes. You can literally create manually every mesh set of your model in midas NFX. So you can input the nodes and the position of the nodes, and you can draw each of the mesh. Of course, no one will do that because it takes a lot of time, but I'm just telling it because some people are wondering about that. And if you want to get a great model and you have the time to build it, then midas NFX is a very good software for that. And then you have all the operation, extrusion, revolve, sweeping the mesh or projection, all that. So those are more visual examples that will talk you more than all those words. So for example, revolving, so you can create your 3D mesh directly from a profile and revolve it, for example. So you will get very nice meshing. So it's very useful if you're doing, for example, hyperelastic material analysis. So you can project and create some profile like that for some structural elements. You can do the offset of the mesh. You can do a lot of operation in order to create simple but model that will give you some real results. Now a surface map measure will give you a really nice mesh like that, fully in quad. You have solid map measure as well. So quad measure, and those images are some things that are taken from real projects. So people are using that to really get the best accuracy as possible on these kind of analysis. Now I think Piotr has some things to show you on the meshing side as well, so I will give him again the control, and he will show you some few example on the meshing.
Okay, thank you, Cyprian, again. Okay, so I would like to back for the moment to the previous operation, because actually I haven't displayed every kind of the geometry, so I have some doubts that maybe you don't understand necessarily the reason for the Boolean operation according to the autoconnect. So for that, let me quickly back to this, so I'm deleting the unnecessary geometry what I made, and right now I'm capable again to explain you what this operation did. So basically, as you see, this operation, Boolean, autoconnect Boolean operation, it works like Boolean empt, cut, and projection in the same time. So because now we have three parts, so the shaft has been splitted, and if we display this circle, we also see that the imprint, the face has been imprinted on the gear geometry. So that was all. So the next question comes from the customer who is working with another package. Basically, he's working with Nastran software, and the question was like that I was working with Nastran for several years, and I have a lot of models saved in this FE format, like PDF. And so the first question was, of course, can I import this file? And the second supporting question was, what can I do with this model according to the geometry? Is it any way to create geometry based on the mesh? Because as we know, then working with the geometry is much more convenient, much more easy according to the application of boundary conditions and the load. So the customer is looking for the way back. So from the mesh, he wants to create some kind of geometry, and this is very difficult task, and it depends on the complexity of your geometry, obviously. But it's possible. So the answer about this question is yes and yes, but let me show you some let me give you some details about that. So first let's import the Nastran file. So I'm going to this comment, and let's import the file. So we have Nastran file. So two extensions are acceptable by midas NFX. So you can import NAS extension, which comes from the NEI Nastran. Currently this is Autodesk, and MSC Nastran, which is PDF. So let's import the geometry. Let's import the mesh. Excuse me. That's the difference. So as you see, this is FEA model only. So if I go to the mesh, my model consists of the shell elements. So what can we do? How we can create the geometry based on the mesh? So in the latest midas NFX version, we have an option which is present on the geometry inside geometry tools, and is present inside. It's available inside others layout menu. So, and the name of the tool is called Convert Element to Face. So basically, this is the tool that I would like to show you. So we can select the objects, we can select 2D elements, we can select 3D elements if our mesh is 3D solid mesh. So let me select one element, and let's say I would like to create geometry for this long side plate. So what is another challenge? Another challenge is to select all of elements efficiently. So we have to have some supporting tool like selection tool, which will make our selection more easier. So midas NFX has this type of tool. So that's the basically selection toolbar, and clicking on this option, which is called select neighboring edges of surfaces, you see all elements from this plane has been selected. So this is very good. This is very efficient tool and very efficient feature according to this case. So the next thing we have to do is to provide the path to the parasolid file. So our geometry will be exported using this extension, and we are clicking OK. And let's import the geometry we just created. So let's select the part and let's import. So as you see, now we have a geometry, so let me hide the shell, and exactly the same number of the surfaces has been created. So what can we do with this? Of course we can create one single face, and we can do this by Boolean operation. So if we click on surface button and if we select all of the faces, the option merge faces should be checked. We can create one face, and this is basically the way how to extract geometry from the meshes. So if you want to work with this geometry, because sometimes there is additional need to modify this geometry, we should not forget that we are working with the geometry which based on the mesh. So according to the quality of your mesh, the quality of the geometry will depend. So sometimes you can also look for additional tools, for example, to edit this geometry what you made. So I would like to give you some advice that there is an option there is a tool which is called Explode, and based on that geometry we can extract some sub-shapes, like for example curves or faces. So now if we extract the edges, and if we hide the plate, you will see that we have edges only. So now we have an access for modification of this fillet. So we can easily create some nice looking fillet, and after that we can also repeat the operation of creation of the face, and we can modify this geometry. So that's the way how to extract this. And the last example is also related a bit with the geometry, but this time it's also but this example is also influenced by the loading condition. So basically the customer was asking, how can I find the weight center of the solid geometry? Is it a way to create a mass center? It's a very common question, especially when you want to work with the remote loads, or you are looking center of the mass to assign some specific boundary conditions. So it's very important as well. So as you see, we have at this model we have some kind of frame which supports the engine block, and let's assume that we want to replace this geometry by concentrated mass. So how to do that? So basically, if we go to the static loads, there is a command which is called remote load. And there are two methods to work with this tool. So this time I will use parts to use this tab. So I will use this kind of approach. So basically, let's go to the geometry tree and let's hide for the moment the geometry of the chassis. And let's try to create some remote loading. So first of all, I have to apply my load on some faces. So this is why I'm as the object I'm selecting the face, and now I'm selecting all of the supporting faces. So now I have that. The second step is to select the geometry of the engine. So now I have this, and under load type there is an option which is called create mass. So everything is nice and everything is easy up to this moment, because we don't know what is the mass of the engine chassis. So we have to fill in this value manually. So temporarily, let's specify the value of 1, and let's click on OK. And I will show you the result. So right now, if I hide the geometry of the engine, you see that we have graphical representation of the load with some dot which represents concentrated mass. But this concentrated mass is still 1. So we have to find the way how to calculate quickly the weight of the part. So let me show you how to do this. So I will display engine block only. So we have that. So this time it will be very useful to use properties options which are present inside the left panel. So if you select this geometry, the properties should be displayed for this particular geometry, and there is an option which is called material. So you have to select the material which is related with your geometry. So right now I have steel only, but I can create quickly another material, and I can use the database, and let's use some aluminum alloy. So let's use this, let's close, and right now I have this alloy under my list. So I'm clicking, I'm selecting this type of material, I'm clicking on apply, and when I select this geometry, and if I go to the if I click on this position, you see that the mass has been calculated automatically. So the only thing left is to back to this remote load and correct the value and specify the number like 45 kilograms or 40 kilograms, and right now everything is correct. So that was all according to the examples what we prepared today. Right now I'm giving microphone back to the Cyprian, and thank you so much.
Thank you very much, Piotr, for this very nice presentation. So I think we still have a few slides, because for the moment I only talked about the pre-processing. So we'll talk also about the different type of analysis that you can handle in the software. I didn't describe the number of loads and boundary conditions that you can use. So on this slide you can see all the loads that are available. So you have also not only the simple normal loads like force, pressure, self-weight and all that, but you have also like a bolt load, a remote load or bearing load. So this kind of thing also is very important to simplify the modeling and do something faster. And then this is called a subcase. So I like very much this because it's very convenient to simulate different boundary conditions at the same time. So if you have different forces applied to the model and you would like to test the combinations of these forces to see what is the difference, you don't have to build like separate models and then check which model has what like that. You can build everything in one unique model, and here on this subcase window you can dispatch the loads in different subcases, and then when you launch the analysis it calculates everything at once. So that's very useful as well. Then you can put also some factor and load scale factor. So if you are using codes or something, you can also use this feature. It's very useful. Now let's talk about the features of the solver. The feature of the solver. So midas NFX, as I was telling, has a lot of different types of analysis available. So it's not only linear static analysis, which is the most basic and the one that if you're checking a design or something, you will probably only use linear static analysis. This is the most common analysis used, but you have to know that, and you know obviously that there's a lot of hypotheses that are into linear static. First is linear and secondly it's static. So a lot of models cannot be analyzed as linear static because you may have large deformations, you may have non-linear type of loadings or of contact between the parts. So midas NFX also provide non-linear analysis and all types like of other analysis, model buckling, heat transfer or thermal stress analysis, fatigue and dynamic analysis, and also nonlinear dynamic analysis, so NCFD, and also all that integrated in one environment. So I'll give you a bit more details about each of those analyses right now. So as you can see in this analysis case, the 35 analysis types available in midas NFX are directly available in one unique window. So once you build one model, this model can be the basis to perform linear static, but not also nonlinear dynamic or even CFD. So that's something unique in midas NFX because you have only one software to learn and then you can do much more complex. So you are very proficient to do some very difficult and more detailed analysis with the software. So you can use different, so in linear static analysis, for example, you have available the linear contacts as well. So you have welded, you have also sliding contact, so it authorizes a small sliding between the parts. In model analysis, you have you can combine the model with the press stress, for example. So that's something very useful in some cases, and you can also use contacts. And you know, this linear sliding is something that is sometimes very useful and can change a lot the behavior of your assembly. So if your software is only providing like glued contact or what we call in midas NFX welded contact, then you may get inaccuracies. So as you can see here, for this frequency response analysis, there's a big difference in the peak whether you use general welded contact or a sliding contact. Now buckling analysis can also be done. So of course linear buckling, but also non-linear buckling. So we have all the thing which are useful to check the nonlinear buckling in nonlinear static analysis. So you can use for example, the eigenvalue sum check and all that. You have heat transfer and thermal stress analysis. So for example, this example of this is projects that from our clients that we got. So you can consider not only heat generation, conduction, convection, but also radiation. So which means we have nonlinear thermal analysis as well. And this is another type. So in heat transfer analysis, something which is very let's say common is the fact that you want to know when the regime will be achieved. Yes, so when you will get when your transient regime will be finished, and then you will get the stable value of the temperature in all the model. So for that, for example, you can use temperature sensors. So you can put that in one face of the model and it will sense the temperature, and when the temperature reach a stable steady state, then the analysis will automatically stop, so you don't lose time calculating steps which are over the steady state. So that's something also quite interesting. You have linear dynamic analysis. as well, so both transient response, so time response, or frequency response. You can convert dynamic loads into static load into dynamic loading, for example. You have also random analysis, or you can consider pre-stress condition. We have also response spectrum analysis. So if you are analyzing a seismic response, for example, and we have a database of spectrum data inside midas NFX. So it's something that all the software don't have. So you can directly get the spectrum of different seismic data. Now, nonlinear material and geometry and contact. So 3 types of nonlinearity can be analyzed. So we have not only elastoplastic model, but also hyperelastic, which consider different kind of models like Mooney, Rivling, Ogden, or Blatsko. And now we have also nonlinear elastic. So you can use all those models to simulate your material. We can consider large deformation, nonlinear contact, so general contact, Ross contact, self-contact. You can consider friction, and that's all. And nonlinear explicit analysis, so again supporting the 3 types of nonlinearity, but this time in a dynamic environment. So we have explicit and implicit, and both can be coupled together. So explicit is generally used for a very short time frame events, so like a drop or an impact, like you can see in here, impact of the head on the panel of the car. So whereas the implicit is used for a bit longer time step, so you can couple both to analyze more complex events. And then after that, some quite advanced features are available, like separation of contact, the region material, or restart function. So you can, for example, if you are doing nonlinear analysis, you can stop the analysis up to a certain step and then restart from this step to continue the analysis. And this is very useful when you have analysis which take a lot of time, and with a big model you don't want to start again every time at 0, every time you have to compute again the things. And midas also support parallel processing using the multi-core processors for the solving. So this is integrated in, let's say, the normal version of NFX integrates that, which means that it's not an additional paid option or something like that. By default, you can use all the cores of your computer. So if you have big workstation with 16 cores, you can use all the cores, and you'll get some really fast analysis. Now, also a particularity of NFX is that it integrates optimization types of analysis. So that's something that is quite interesting, because actually this year a lot of people are interested about topology optimization. So you can do that in midas NFX as well. So if you're not familiar with this, actually what it does is that you give the software a certain design volume, then you give it some boundary condition and loads that you would apply to your model, and the software will automatically optimize the mesh density of your model in the areas where you have the highest stresses. So then you get some part which is optimized by the software. So these kind of parts will be the basis for your creative design process. So the software will give you some recommendation on how you can get a better design of your product, for example. So that's very good. So for example, this is a real project as well. So as you can see, the part which was like that has been designed using optimization, and the part that you get finally is like that. So if you compare the two parts, you see that there's a big difference between the design that the designer would have done with experience and the final design which has been done following the recommendation of the software. So that usually not something that you can guess, so that's why this kind of analysis is very useful. You can also use optimization in frequency response analysis, for example, in some cases like this one. Now NFX also have fatigue analysis, supporting different fatigue types of analysis, SN analysis, EN method as well, and different other type of methods. So we did a webinar about that last year, so you can find it on YouTube if you're interested by fatigue. I will not detail that too much today. We have also composite material which are integrated in the standard package of midas NFX, so you can use 2D and 3D composite material, both supported in linear and nonlinear analysis. We support different type of failure theory, like Hill-Hoffman, Saiwu, maximum stress, maximum strain, and Nasal-Lark. Different failure criteria as well. And you can also calculate view the ply result by elements like that. This is very useful. And now I finished to talk about the analysis types, and now I still have a few slides about the post-processing functions. So midas NFX allows you to export your results into different formats. So you can of course view that in the tables and export in Microsoft Excel directly from the software. You can also view result directly on the model, so you can view on curve diagram like that. It's very impressive. And you can use the probe tool to probe at any point of the model the results. You have some generation of reports like in Word format, so you can tell the software what kind of result you want in your report, and it will automatically take some screen captures and put you a MS Word format report. So the format itself of the report can be changed as you want, so this can be customized if you have your own company template, for example, and this is very good and saves a lot of times. And we have a second type of report which is called 3D PDF. I'll show you an example right now. So this is, for example, what you would see in the 3D PDF. So that's a PDF format, it's not a software, and you can visualize the model in 3D, so you can rotate it like that, you can zoom on it inside a PDF, and on the different pages of your model you can basically see the different type of results. So for example, this is analysis where I analyze the impact of this inside the turbine. So you can view the result like that in your 3D PDF, and you have the scale for the result. So it's very useful because you can share this PDF with some other people. Maybe if you're doing a project for someone, for example, you can send him the model and he can take a look himself. That's much more efficient than taking 1,000 screen captures just to show some simple thing like that. So that's it. Now this is one slide just to show you the performance of the solvers. So midas NFX has very fast solvers and which support 64-byte computation. So we have different types of solver, the multifrontal and the AMG solver. So as well, if you want to know how different solvers are working, etc., we have some video on the website which is explaining all that. And you see that for analysis of a model which has 150,000 elements, it takes only 149 seconds. So it's quite fast, and in reality you get models which are much bigger than that. So the time it takes to calculate is actually very critical thing for a lot of people. And finally, of course, we are doing some benchmark test and verification of all the analysis. So NFX always gets very close to other software, so you can find those kind of comparison on our website as well. We have also all the NFX benchmark, so if you want to check that, everything is available. So that's it for today. So the next webinar will be about linear static analysis, and it will be next month. So we will receive the link by email if you want to join the next webinar. So now we'll have a final question and answer session. So if you have some question, please ask them in the chat section, and we'll take few of the question and we will answer about them in live. So please just write your questions, and then me or Piotr will be here to answer.